Hello, Sackville, year 11. I hope you're all good. Please do say hello in the comments. It would be excellent to get a chance to welcome you. I can see there's one person there so far. We had a couple more. So do jump in. Do please say hello in the comments and I shall welcome you. I hope you're well. I'm personally a little bit sick of the rain, but let's not focus too much on that. Do let me know if the sound isn't great or if the picture is at all strange. All right, so I think I'm going to crack straight on with the topic today because it's actually a huge topic and possibly slightly ambitious to try and get this done in an hour, but let's see how we do. So this is computer networks, a bit of a mouthful. This is computer networks, connections and protocols. There is a massive amount here, and bear in mind that I'm trying to put about, I suppose, 6 weeks of teaching into 45 minutes, but it can be done, as we're about to see. This is probably the largest sort of area in paper one, and I think it's the most technical after the CPU. Once you've got the CPU registers, that sort of thing. I'll do some quizzing later on, but I want to crack on and just sort of get through the early parts of this, and then we can maybe pause and do some quizzing after that. So this is networks and topologies. It's 1.3, and it starts off with types of networks. Now, opening question you're going to get in the exam is something like, what's the benefit of using a computer network? And the key phrase you're going for here is the word share. It appears here, and it actually appears in more places too. So what's the benefit of having a network rather than a standalone computer? It's because you can share files, you can share resources, you can share an internet connection, you can share all sorts of things. Also, you can communicate with people. Forget that roaming profile thing. On the negative side, it means that you're reliant on network resources, and if those resources go down or break, you might not have access to them. Also, network hardware is expensive, and there's a risk of being hacked or having viruses which could bring your system down. And then equally, you need specialist staff. Specialist staff are expensive and they need to be paid. So that's the issue with the pros and the cons of using networks. Right, I'm sure you recognise this. You've got LANs and you've got WANs. You've got your local area network and your wide area network. There is nearly always a question on this right at the very start of the exam. And what they're looking for is really a key set of words, and these appear, I would say, almost in every single paper. What is a LAN? Well, it's a connection of computers and devices. That's the first thing. And the other thing that you should say is that it covers a small geographical area. Now, if they're trying to sort of offer more points for this, more marks rather, you could then talk about ownership, okay? So the ownership, so for example, most schools own all of the infrastructure, the computers, the routers, the switches, the cabling, the servers, the storage. Most schools own all of their own kit. So that's a difference between a local area network, and I'll jump straight in, and a wide area network. So the most famous wide area network is the internet. And of course, a wide area network it covers a large geographical area, or even worldwide in the case of the internet. And it could be a bunch of LANs that have been connected together across different geographical locations. So that is the difference between a WAN and a LAN. What you can't say is that a LAN covers a local area, because it doesn't even make any sense. So you do need to use that phrase that it covers a small geographical area as opposed to covering a large geographical area or even worldwide. Okay, so that is the difference there. Those are your types of networks. All right, let's jump forward. Network performance. If you are a keen gamer, this might make some kind of sense to you. Is that, my picture went funny there. I'm back in the room. So let's have a look at these. And this is, I suppose, like many things, this is a list of 5 areas that you need to learn. So let's have a look at these. Right. Network performance. So in other words, what will make your data travel faster, more quickly, or more slowly around the network? And the answer is these things. You first of all got bandwidth. Now, people often don't quite understand what bandwidth is, but bandwidth is, and here's the definition, bandwidth is the maximum rate of data transfer, and it's measured in bits per second. It's got to be measured in something after all. So when your parents or your carers go and buy their monthly package from Sky or Virgin or BT, whoever it is, you are ultimately paying for bits per second, how quickly you can have that data bouncing around your system. And of course, if you've got a faster data transfer speed, then you can transfer data more quickly. You can have more people watching Netflix. You can do all sorts of things. However, the sort of the converse to that is that if you're sharing a connection with other people, well, then they're taking a chunk of your bandwidth, so things will slow down. You may well have noticed this during lockdown, where things slowed down dramatically because there were so many people sharing the same internet connection at home. So then you've got transmission media, and that is the media, whether the data is being carried by cables or being carried wirelessly, and the type of cables they're being carried by. So, for example, copper cables, cheap as chips, quite fast, easy to lay, easily available. And then you've got fiber optic cable, the more sort of Gucci option, which is not quite as easy to lay because it's not very malleable. It's quite hard to bend. It's very expensive, but it's super fast, great outside. So transmission media, that will impact on how quickly or how slowly you actually carry the data. Then you've got this. Error rate. So, for example, if you're sending data packets around a system and they collide, then that means that data is lost. So, a system will always generate some errors, and the more errors your system generates, the slower the worse the performance of your network will be. This, if you're a gamer, will make a lot of sense, which is latency. You call it lag if you're gaming, and it means that although you've shot someone, in fact, you've already died because they've got a quicker connection than you. So that's latency, which to you would be known as lag. All right? Good. I know I'm rushing. I'm going to keep rushing for another 5 or 10 minutes. All right? Now we get to the one that students often really struggle with. And this is the role of computers. And you've got client-server versus peer-to-peer network. Well, one's quite straightforward to understand and the other one is slightly more complicated. So let's jump in and look at peer-to-peer. Peer-to-peer is really simple. That's when you simply join two computers together with a cable, okay? Which means that you're sharing resources. And the client server is different because you've got two different types of computers, one called a client and one called a server. Right, peer-to-peer. In a peer-to-peer network, or connection, all the devices, whether they're computers, whether they're mobile phones, doesn't matter, they're equal, okay? They are equally important within the network. And all the devices just connect to each other. The files are still stored on the individual device. Think about at school where all of your files are stored on a central server somewhere and you're accessing it from there. You realize in school that the files you're accessing aren't stored on the computer that you're using. They're stored elsewhere, okay? But in the case of peer-to-peer, the files are going to be stored on individual computers, and then you've got to share them with other devices. Now, this is not a solution that you would use in industry. This is something you might do at home, and usually it's to connect things like printers to your... So it's not just computers. That's why I use the word nodes. It's any device on a network. So that's what the peer-to-peer is for. And really, it's for domestic situations rather than in business. Okay, the good thing about peer-to-peer, it's easy to maintain, doesn't require technical expertise, it's not expensive, just need some cables, and you're not dependent on a server. On the other side, there's no centralized management, which means if you're going to update, I don't know, say you want to update Windows on the three computers in your peer-to-peer network, you've got to go to each computer and install Windows on it separately, which takes ages. Making backups is much harder, and copying files means that you might create duplicates, and it's quite hard to keep track of the latest version of files. So it's less reliable and it's much slower than using the more sort of Gucci upmarket solution, which is client-server network, and this is what business tends to use. Your school may use the client-server network. In fact, I'm pretty well, your school will use the client-server network. So the difference here is the network is managed by the server. A server is a really powerful computer that's got storage attached to it, racks and racks and racks of hard drives, okay? So you've got the server that's the powerful computer that's doing all the heavy lifting, and then you've got the client. So when you log onto your network at school, you are a client, and when you ask for information from whether it's web pages, whether it's opening your files, they are served up to you by a server. So you'll send your request, and the server will go, oh, okay, you want that file, right? I know what that is. I'll pick that up, and I'll send it to you. And that's literally how it works. So they're called requests, by the way, when the client asks the server for some data. So the server can also store profiles and passwords, and it can be set up with access levels, which is what you see at school. So your teachers probably have different levels of access to you, and probably even within teachers, you've got different access levels set up there. Okay, web servers is the same thing. They actually serve you up web pages. Pros and cons. It's the idea that you can do things centrally, which you can't do if you simply plug computers into each other when they're all equal. So in other words, you can keep track of centrally stored files. So you're going to store your files on the server and then serve them up to the individual computers as and when you want them, which is, of course, what happens at school, because it means that you can be in the computer science room and open your homework there. And if you're in the art room and you want to look at some artwork, your work that you've saved, you can still open it from there because it's all centrally stored, which is one of the most important things of it. Performing backups is really easy. You do it once and it covers the entire system. Installing software, so think about peer-to-peer, you go to each computer with a CD or doing it via downloads, and then you've got to go through the next to keep updating it. Whereas this, you can literally install it once and then it just rolls it out across all the machines, okay? It's great for security because you can manage it. You can manage it centrally. So you can install your anti-malware, your antivirus, all the rest of it. You can introduce access levels to give tiered levels of access. And it's reliable. Servers are reliable. They're always on. But they are expensive. Now, they didn't do a big question on this in the last exam, so there is a reasonable chance that they may go for this time. No guarantee, but they may do. The other issue is it requires specialist knowledge, and where anything requires specialist knowledge, it means someone needs to be paid, and if you're a specialist in IT, your salary will be quite good, so it's expensive to pay the people to do this work. And then, of course, you've got a single point of failure. So if the server goes down, well, you can't do anything. You just sat there. And you'll know that. That's when your computer science teachers are running around looking very stressed. It's because the server's gone down and they don't know what to do anymore because they haven't got PowerPoint. The servers can get overloaded if too many clients are using it at once. Not an issue in school, but that is... So there we go. That is your client-server networks. We've got peer-to-peer, computers plugged in together, client-server, a big, powerful server computer that's serving up files, and all of the clients are the sort of... they used to be called dumb terminals. That was another version of it where they're just being served up data that the user is requesting. Right, I've moved quickly. 13 minutes. That's about 3 weeks of teaching there, so I hope you appreciate that. 3 weeks and 13 minutes. And don't forget, you can play this at half speed. That's why I'm speaking very quickly. So network hardware. These are the 5 different components, the network devices that you need to be able to really define and explain how they work. So I'll jump straight through them. And obviously, I will send you a copy of this so you can use this as part of your revision schedule. But fundamentally, we'll start with wireless access points. Now, wireless access points, and I've got one up here. I mean, like most things in computer science, it's either a black or a white box. This is a white box, and you can see that one's made by Cisco. Right, it's a hardware device, and it allows wireless capable devices to connect to wired networks. Let's just unpick this for a moment, right? So this device, the wireless access point, the WAP, this would be connected to a wired network. and it would allow you on a wireless device like a phone or a laptop connecting via Wi-Fi to access the internet, okay? We'll talk about internet versus Wi-Fi a bit later on, but that's the key thing there, okay? The connection is usually made through Wi-Fi, or it can be made through Bluetooth. And that's when people talk about hotspots. That is what a hotspot is. It's a wireless access point, but it's not the same thing as the internet. A router. OCR love a router question. They find it almost impossible to resist doing a router question, whether they're doing an IT exam or a Cambridge Technicals or a Nationals exam. They just love a router question. So make sure you know exactly what a router does. And there's a reason why the router always turns up. It's because it does lots of stuff. So let's run through some of the stuff that it does. So the router, first of all, it receives data packets. We know that part of TCP/IP, the Transmission Control Protocol, Internet Protocol that Vint Cerf and Bob Kahn invented in the 60s, that's the protocol, the set of rules which dictates how data is sent around the internet. So the router receives packets and it forwards packets within the network. So it's a bit like the post office. It's dealing with packets in, packets out, and the packets are your information. It could be a VoIP, a voice over internet protocol. It could be, I don't know, something like FaceTime. Okay, it could be Zoom, that sort of thing. Okay, or it could be a file that you send. So it also transmits the packets to different networks, and it will look at the final destination of the packet. It is like a postman. It looks at the final destination of the packet. It identifies the best route for the packet to take. So imagine you're sending an email to Florida. Well, your email is going to get bounced off. The packets of data within your email, because it'll get chopped up and sent in little packets, and these packets will get bounced off the nearest working available router. So all of these packets get sent off, and they could go via completely different routers to end up to their destination, okay? So it looked at the most efficient path, and then it also assigns IP addresses, Internet Protocol addresses, a series of numbers, 95.2.6.84, for example. And it converts the packets from one protocol to another. You don't need to know this, but in terms of when you're using a local area network, which uses the Ethernet protocol, they're not called packets, they're little chunks of data, they're called frames. It's much the same principle, but it's a different set of rules, a different protocol. Whew, that's routers. I really recommend that you maybe create a mnemonic for remembering router, because they do love a router question. I also think wireless access point is just one line to learn, but routers, it's really worth spending 5 minutes making sure you're happy with what a router does. I put this one in there just so you know there's also a wireless router. Forget this top one. You don't need to know that. That is irrelevant. That's just me being officious. Obviously, it doesn't use cables because it's wireless, but it is slower. You get slower data transmission speeds with a wireless router than you do with a wired router, but it's far more convenient. And that's why we all use them, because we will accept a hit in bandwidth, in transmission speed, but a wireless router is just so much less hassle than having cables that the dog falls over and chews. This is a switch. You've probably got one of these in your classroom. It'd be a gigantic box fairly high up with lots of ports, about 30 ports, and lots of flashing lights. This is your switch. I'm going to switch, and just all you really need to know here is that bit that I've highlighted, which is it switches connection between ports and devices, okay? And it makes full use of the bandwidth, so therefore you get no data collisions. Switches are an integral piece of hardware that are needed to form a network. Then we've got this guy here, the network interface card, which looks like this. Your computer or laptop will have one of these cards, which, and you can see here the little connection. Come on, there we go. The connection here, that's what pushes into the slots of your motherboard. And this here is the bit that pokes out the back where you plug in your Ethernet cable. And that here, that would take a Cat 5, Cat 6, Cat 7, Cat 8 cable, the one with the little clip on the end. that people sometimes unplug from classrooms and it drives you mad. So that is your network interface card. What does it do? It connects a computer to the network. So you can use this port here to plug in your Ethernet cable and then plug that into your router. Okay. So these can be cabled or wireless. And in fact, some of these are both. They're cabled and wireless, which they often are these days. Think about your Xbox or PlayStation. They've got a cabled and wireless router included. It uses the Ethernet protocol. We'll come on to protocols later on, and that's for a local area network. It uses a UTP copper cable or coaxial cable, and that's the Ethernet cable, and it's often incorporated into a motherboard. It's just plugged into a motherboard. It's a separate device. We have got 5 people here. Hello, I know I'm going fast. I hope this is useful. If you've got any questions, just ask me. I know I'm going at the speed of light, but literally I am here to help you. So I'm going to rattle through this unless you stop me, okay? All right, network interface cards. Next, we're going on to transmission media. So that is... This is actually part of network devices. Just so that I'm sure you know this, but this is called a CAT cable. I can't actually remember what CAT stands for. It could just be category. It's got this little clip at the top here, and this is the cable that plugs into your network interface card that you would then plug from there into your router. So this would carry your internet feed, this cable, and this works along the local area network, okay? This would work on your LAN. All right, so that is your Ethernet. Right, so now we're going to look at different types of transmission media, which is a fancy way of saying cables or wireless, all right? So we've got, in a wired LAN, in schools, we all use copper cable because it's cheap. It's cheap as chips. It does the job. It's got good data transmission speeds. It's reliable. It's easy to replace. It's easy to lay. It's the best solution because it's inexpensive. It does all of these things here. It's thin and flexible. It's the one that you find nearly everywhere. Okay, it consists of UTP, which is an unshielded twisted pair. Now that sounds quite concerning, unshielded twisted pair, but it just means these cables are twisted around each other. If you look up here, these cables just twist around each other, and that's because it reduces interference, okay? You don't need to know that, but it's quite interesting. All right, so then we've got the Gucci solution, the Armani, the Hugo Boss of cabling, which is fiber optic cable. Fiber optic cable is expensive, but it's very fast data transmission speed. That's what it looks like. You've got a central core, and then you've got all the cables around the outside. Okay, so you've got the core there, and then you've got the outer jacket, the strength to give it strength. That yellow bit you can see there. You've got a coating, you've got some cladding, and then right at the center you've got the fiber optic cable itself. Now, fiber optic cable. It's incredibly. It uses glass, and it uses light and pulses of light, and it's very reflective on the inside. So your data is being carried along pulses of light, and as you may remember from science, light travels quite fast. In fact, it travels at 186,000 miles per second. According to Einstein, there's nothing quicker. So therefore, sending data using light is incredibly quick, and it's much faster than copper cable. So that's why, you're sort of thinking about, do I go with Virgin Internet because they've got broadband, or shall I go with BT? They haven't got fiber optic cable, but it's still pretty quick, and you get much faster data transfer speeds with fiber optic, okay? Fiber optic, frankly, has got all of the advantages in that high performance, no data loss, so you don't need boosters. If you use copper cable and you're laying it over, you want to send a signal, let's say 20 miles over copper cable, every couple of 100 meters, you've got to put in a booster to boost the signal because it keeps dropping away. Not with fiber optic. The signal just carries, okay, just carries along those pulses of light. No interference. Not a problem putting it under the water. So the cables that run between us and the UK and under the Atlantic going to the States, they're fiber optic cables because they're not bothered by horrible conditions. If you leave copper cable out in the back garden for a year, it just go rusty. It snaps when you sort of try breaking it. It just snaps. Fiber optic is incredibly robust. Only problem is it is massively expensive, okay? That's the issue. It costs a lot of money. Okay, fibre optic cable. Tick, we have done that one. Internet, I'm going to do one more, and then I'll see if any of you will answer any quiz questions. There were a few that got answered last time, but let's see how we do. Internet, 25 minutes in. Bear in mind, 6 weeks teaching, 45 minutes. Let's see how we do. The internet, they will often ask you a question, and this is at grade 3, grade 4. Do you know what the internet is? Can you define what the internet is? Well, the internet is a network of networks. It's the biggest wide area network, and information is shared via the World Wide Web. And it's kind of worth reminding you that the internet is all of the infrastructure. It's the routers, the switches, the cabling, etc. It's all of the physical stuff. The World Wide Web is what you do on it. Okay, so it's a bit like the internet is the train and the World Wide Web is the passengers. So I talked earlier about the TCP protocol, and the internet is reliant on the TCP IP protocol, the transmission control protocol, internet protocol. And these two sets of rules govern how data is transmitted across a wide area network. Invented in the 60s by a guy called Vint Cerf and Bob Kahn. They sort of headed up the team. And the reason that this was invented in the first place was because America was paranoid in the 60s about had Russia bombed their big cities, they'd have had no comms at all. So having a system like this, where you could take out, if you bombed New York, for example, everything else would still work around it. So that's why they wanted a system where they could still communicate across the USA, even though one of the nodes had been taken down. Okay, so that's where this came from. This came from sort of paranoia about Russia and communism, and it ended up being used to buy things on the internet and for social media, which no one envisaged. So it uses the HTTP protocol, the internet, that is, when you go on the World Wide Web, and it's reliant on something called URLs, which is a uniform resource locator, which is the address you type in, like bbc.co.uk, okay? So that's an example of a URL. Your school's got a URL. Those are the words we type into the address bar to actually access resources. So the key takeaway here is it's a network of networks. If they ask you, it'll be a 1-mark question. That's what you need to say. All right, now things are going to get complicated here. We've got 5 people in. Domain name system. Now, a bit confusing, right? Because DNS stands for domain name system, domain name service, and domain name server. But to be honest with you, they all kind of relate to the same thing, all right? So let's think about web pages, and let's think about web addresses. So we've already established that something like bbc.co.uk, that is a URL. It's a uniform resource locator, okay? Now, computers don't understand words. They understand numbers. So therefore, there has to be a way of translating bbc.co.uk into a series of numbers, like this here. Handy that's there, because that's what I'm talking about. So, for example, Nike.com, the domain name is there, Nike.com, and it could be /shop. /trainers, where, you know, whatever that page is where you load up to go and look at your trainers. But behind that, there is a number, which is the IP address, the Internet Protocol address. Can you remember TCP/IP, the protocol that sort of underpins the entire internet? Well, the IP address is the one that is important. But the reason we've got domain names like Nike.com is because we wouldn't remember, oh, I must go to 192.158.1.38. I mean, I still can't remember my wife's phone number. We've been together for 35 years. I honestly can't remember it. So that's why it would be hopeless if we had to remember numbers to type them in, okay? So there had to be a translation process for those two things to happen. So we access things as humans, which is kind of quite clear because we are humans, through domain names. But web browsers interact through IP addresses. This is where, been quite a long build-up here, this is where DNS comes in. The domain name system is responsible for converting domain names like this into IP addresses like this. Pretty straightforward, isn't it? And this means that you can access resources. They've got to be updated regularly, and there are a number of domain name servers and domain name services, okay? Well, one domain name service, multiple domain name servers. And between all of them, and usually, or not usually, always, the domain name servers, which are big computers that hold, if you like, these tables where the information, where they'll get a request that says, do you know what the IP address for Nike.com is? And the first one will say, yeah, it's 192.158.138, okay? No problem. But they tend to be geographically based. So if you're in the UK and you want to access a web address in India, it might need to go and ask a domain name server over in India. So the UK DNS will bounce it over to, it'll literally be saying, yeah, I know somebody who might know that, and it'll bounce it off to that DNS. So that's how it works. They like a question on this. This is quite technical, and you will need to go back and look at this list. But the fundamental notion that domain names are words and IP addresses are numbers, and computers only use numbers, should get you really started on that journey to understanding that. Okay, we're into hosting now. Websites are hosted. That is blinking obvious, isn't it? Because websites have to be somewhere. So you would have a business who uses its server, a big powerful computer, and some storage, some solid state or magnetic drives, to store the files, because a website is a series of files. And a web page is going to be text, and it's going to be images, and it's going to be video, and it's going to be a series of instructions for how to put it together, okay? So file servers, web servers, they all perform a task within this, but websites need to be hosted, and they will be hosted on something called a web server. And websites will have a domain name like Nike.com. And these domain names are registered with the DNS, domain name server. And the domain name points to the IP address where the website's hosted. I'll say that again. The domain name points to the IP address. And again, we've got this notion of a domain name, something like Nike.com, will point to an IP address, which could be 95.62.93.1. Okay? And that's how it works. It would be really good to pick up some marks on this, because students often find this particular part of the course really quite challenging. But if you can get your head around those basic concepts, you could be scoring marks fairly quickly. So when you visit a website, this is the story now. Now, what they often do with this question is that they will do a fill-in-the-blank exercise. So as long as you've got an idea of how the story works, you've got a good chance of picking up marks here. And so for example, this page you're looking at here in front of you, they might pull out web server, they might pull out IP address, they might pull out some keywords from this, but as long as you know the story behind it, first of all, go through it and fill in the ones you're absolutely certain about, if it's a fill in the blanks exercise, and then go back and then sort of try and make the best guess for what's left. So the way it works is that you enter an address, a URL, a uniform resource locator like that one, okay? And you type it into a browser. Then the domain name, gcsecs.org, is looked up in the domain name server. A public IP address of web server for the website is found in DNS, so the IP address is then found and it's returned to the web client. I mean, all this happens in a fraction of a second, so there's an awful lot. When you type in bbc.co.uk and press enter, if that address, if the IP address isn't held in your cache memory, then it bounces it off the DNS, the domain name server, and the domain name server says, oh, yeah, no, I know this one. We've got that. It's 192.64.3.8.2. It sends it back to your browser, and then your browser then goes to that page and opens it. So there's an awful lot happening behind the scenes. And that's how it works. I recommend taking a bit of time to go through that to make sure that you are really happy with how that works, okay? But that is the story. And I think it's probably worth spending a little bit of time making sure that you're happy with how that operates. I think that could be when that has appeared in the exam, it has been a big mark question. It's been a kind of 6 to 8 marker, so it's probably worth spending the time to get included in that. I'm sure this is obvious to you, but cloud storage is when you store data online or at a remote location using the internet. So if something's on the cloud, all it really means is you're accessing it via the internet and it's stored somewhere else. But you've also got the fact that software can be stored in the cloud, and also software can be executed from the cloud as well. Okay, let's push on the cloud. Oh, I just missed one? I have. What they're more likely to focus on here is the positives and negatives of cloud storage. Now, there was a question a couple of years ago where they talked about you may have done this past paper question. They talked about it was a law firm. A law firm is looking at extending their storage. They need more storage, and they're considering using cloud hosting. What are the pros and cons for the law firm? Now, students generally said, well, the pros are that you can access from any connected device. Yep. It's easy to increase storage. You just ask them and pay a bit more. Yep. Don't need hardware. Yep. You haven't got to pay for staff to manage the hardware because that's included in your subscription. All of these things I've got here, they said, but they only got half the marks for the essay. And that's because in the question it said, what are the considerations for the law firm? So you had to say that it's easy to increase storage, so therefore the law firm can take on more cases. You can access from any connected device, meaning that lawyers can work abroad. Okay, so you had to include the context. So make sure that you find out, that you ascertain whether the question actually involves having to talk about the scenario. And OCR will take off marks if you don't do that. Quite a few people lost about 3 or 4 marks on that one. Negative of cloud storage. If you don't have an internet connection, you can't connect to the cloud. You are reliant on the host, whoever hosts the cloud, for security, and it is vulnerable to hackers. I mean, to be honest with you, it's the security for most cloud providers is so good that it's not really an issue, but still, it is vulnerable rather than having it sat on your own computer at home. There are some issues with ownership of data, especially when you are storing your files abroad, and of course there's a cost associated with cloud storage. Still 5 here. I'm glad you're here, guys. You've done well. I know I'm going through an awful lot of material. Okay, servers. I've kind of covered this, but I wanted to make sure that you're happy with some of the ideas here. A server stores data to be used by other computers on a network. It's a big, powerful computer. A server can be used for different purposes. A web server hosts a website. It'll receive a request for an HTML page. HTML, hypertext markup language, is the code used to write web pages. And it'll consist of saying what the background color is, saying where things are stored on the page. There's a picture at the top. There's this picture halfway down. There's a video. I want it placed here. So all of that is written in HTML, and the web server simply looks at the HTML, takes all the items, puts it together as a web page, and then sends it to the user. Okay. A mail server, well, it sends and receives emails. And a file server is what you use each time that you open a file at school, using a file server, okay? Or if you're opening something off iCloud, which is where I got my stuff stored, so that would be a file server. So big, powerful computer, lots of attached storage, and it's got a dedicated job. Wow, we have moved quickly. We're on to topologies. We're actually over halfway there. You need to know 2 topologies. Topologies are ways in which you can connect devices together. Okay, so we're talking about different computers here. Now, A star topology is where all the devices are connected to a switch. We talked about switches earlier. That's part of the network hardware you need to understand. You might need to draw a diagram of a star, which I haven't got here. So make sure you're happy with that. The switch receives the data from each device and sends the data onwards to the recipient device. So data can't travel directly between devices, it goes through the switch. So everything connected to the switch, and the switch then sends the data and receives the data and sends it on to the device where it's supposed to go. Okay? Good and bad. When you've got two of these to worry about. The good thing is the switch only sends the data to the intended devices, which means you get fewer data collisions and it's more secure. It's easy to add devices, you just plug them in and there's no disruption to the network. So if someone new comes to work for the company and they need to work on the same network, you just plug in the device, as long as you've got enough enough ports on the switch, and that's it, really easy. Problem is, if the switch fails, you haven't got a network, and you do need a lot of cabling. It's quite expensive to install. So that is your switch topology. Make sure you can draw it. I don't have the drawing. Sorry, guys, I didn't think about that. But you can find that quite easily, and it's not that hard. It's a central switch, which is then attached to everything. Okay. And then we've got the mesh topology. Now, an example of the mesh topology, the internet, for example, is a partial mesh. But the mesh topology works this, where devices are connected directly to each other. There is no switch, and data can flow in any direction. You've got two variants here, a full and a partial mesh. And guess what? In a full mesh, every computer or every node is connected to every other node, and data travels directly from one node to another. And in a partial mesh, nodes are connected to most nodes, but data can hop from one node to another, but not every single node is connected. And that's it. That is your mesh topology. The good and the bad. If a connection is lost, an alternative route is available. So if something goes down, if a computer goes down, if a node goes down in a mesh topology, there's another route to send it, which is why the internet was invented. If we go back to the paranoia of communists back in the 1960s, we've covered a lot of ground today. Mesh Wi-Fi cheaper than traditional large Wi-Fi networks. It's the networks run faster because the data packets don't have to go via a switch. On the negative side, it's expensive if cables are used, and you need security to prevent unauthorized nodes being added, people plugging into your network without you knowing about it. And all nodes have got to be capable of routing. And routing, don't forget, is that post office thing we talked about. The router is when data packets are sent from one place to another. Okay, so that's the routing. I'm being Mystic Meg here. I reckon they'll ask you something like this in the exam. I reckon that they will say, in a building with very thick walls, there is a cafe. They are considering what sort of network to set up. What could you recommend and why? And so they would get you to talk about the different types of networks, what you'd recommend, what the pros are, what the cons are, why you might use a wireless network, why you might use a wired network, which is cheaper, which is less expensive, blah, 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 blah. But all of this, it's not the fact that there's a wrong answer necessarily, it's the fact you've got to be able to argue the case backwards and forwards. Okay, that's the key thing there. All right, wired and wireless networks, protocols and layers. Let me ask a quick question first here and see if anyone's awake. Can any of you, the whole 5 of you here, can any of you name a register that we've covered before? I'll give you a few minutes. I'll give you 30 seconds and see if anyone comes back to me. And if not, I'll abandon doing the quiz. I'll just give you 20 seconds to see if anyone can think of any of the memory registers. The silence is deafening. Not a problem. I will jump back to what I was doing before. I thought I'd give a chance. I planned on not doing quizzing today because you weren't great quizzes. We had a few quiz questions answered, but not many. So I'll crack on. I'll go back onto this. Wired and wireless networks, protocols and layers. Okay, big deep breath, because this is slightly more technical, but still, there's a logical story to it, which is what I like about this. Well, a lot of information here. Now, this is where you need to be able to compare, to understand, first of all, Ethernet versus Wi-Fi versus Bluetooth, what they are, and then in the next one, in the next screen, we'll have a look at the pros and the cons of each, okay? So Ethernet uses copper cable to connect computers to a network. We know it uses the Cat6 cable. That's not important. It's got good data transfer speeds, and it's secure. It's secure because it's cables. Cables are a secure way of transmitting data. Wi-Fi uses radio waves. You don't need to worry about the frequency, but you should know that you can use WPA security to protect yourself, okay? To secure your connection. Then we've got Bluetooth, which also uses radio waves. It tends to work over a shorter distance. It says 100 meters. That's what Bluetooth claim. I've never known a Bluetooth device to work that far. But you know, because you use Bluetooth every day, that Bluetooth is more about connecting, I don't know, microphones, mice, headphones, etc. Okay, it tends to be small personal objects that you'd use for that, whereas Wi-Fi tends to be over a slightly longer distance. So as long as you're aware that it's radio waves and that they've both got strengths and weaknesses, you don't really need to know half the data on here, but that's just there in case it helps you understand. This is really the meat of this. Is there are pros and cons? And I can see them asking you to do a pros and cons question. I was talking about the cafe earlier. So if you were talking about a cafe and you wanted to, say it was a 6-mark question saying, what connection, wired or wireless, would you recommend for the cafe and why? You could say either, right? But I would say I would go for a wireless connection because it means that the users can move around and there'll be no cables, which could be quite dangerous if you were to have cables in a cafe. It's got a lower setup cost than wired, and it means that customers could bring their own phone and they could easily connect when they have their cup of coffee and their croissant. I could say that it's great for connecting multiple types of devices. That should say at the end. On the negative side, you can have unauthorized people joining it, so you might need to think about what you would do there. Also, if the cafe's got really thick walls, well, that might be an issue, but I wouldn't have thought so. But you would say it's got slower data transfer speed than wired. So as long as you're talking about good and bad things about it, then that's that. You could say, I want to do wired. I don't think you would. I mean, how many cafes do you know that have got a wired connection? In the 80s they did, but they don't anymore. So it requires alteration of the fabric of the building. That's a fancy way of saying you've got to drill holes in the wall to put cables through. It takes longer to install. So these are the sorts of areas that if you get a question on wired versus wireless, and equally, if they said it's an office with a set number of desks where people are going to be making videos and sending the videos to a sister company on the other side of the world, you'd be thinking, well, we'll go for wired because connection speed, data transfer speed is really, really important. People aren't going to have to move around, so the lack of flexibility is unimportant. We can alter the fabric of the building because it's an office, it doesn't matter. And while it takes longer to install, the fact that we'll get a faster connection means that it works. So I reckon that might be a sensible place to spend a few minutes thinking, okay, I've got 3 or 4 things that I can say about wired and wireless, and I've definitely got pros and cons for each, okay? That's what you're looking for there. So wireless networks, really common, haven't got to lay cable, haven't got to drill holes, alter the fabric of the building, and it allows you to connect new devices. Wireless networks, the transmission speed's slower, and the security is an issue because the wireless signal can easily be intercepted. there are things that you can do, such as hiding the wireless self-identifier, so that people actually can't see the. So you know when on your phone you're looking for a wireless hotspot, you can actually hide that, and you can restrict access to authorized MAC addresses only. Okay, and you can also use WPA encryption. So you can encrypt the data so that if it is intercepted, it's not helpful. I've got 10 minutes to get through this. It's going to be a challenge. Encryption. Now, like some strange cult, I have made all of my Year 11 computer scientists literally repeat out loud, turns plain text into ciphertext, because it turns up nearly every time. What is encryption? It means turning plain text into ciphertext. So learn that phrase up there, because OCR, don't know if you use it in a lot of exams. And the other thing is that encryption means that if the data is intercepted, it is unintelligible. They can't read it. So even if it gets stolen, even if the data is intercepted by a third party, by a man-in-the-middle attack, for example, it's useless because it's encrypted. It's just a bunch of scrambled data that makes no sense, okay? So that's encryption for you. They love an encryption question. They almost can't resist it. The draw is too great, so just be aware of that. IP and MAC addressing. We're on to week 5 now in our, which I've covered in 51 minutes. IP and MAC addressing. There's a lot of information here, and I don't intend going through all of it, but it works a bit like this. IP addressing stands for Internet Protocol Addressing, okay? We know that an Internet Protocol address is a series of numbers, okay? And it stands for IP address. And it governs, the IP address governs the format of data sent between TCP IP, Transmission Control Internet Protocol, Transmission Control Protocol, Internet Protocol, Vint Cerf, Bob Kahn, the 60s, Paranoia, Communism, the States, atomic weapons. There you go. So the IP address creates a unique address that identifies a device on the network, and it allows data to be sent between device. So it's actually a 32-bit binary number. That's what it's translated into, the 32 to 128-bit binary number. However, the thing they tend to ask about IP addresses is what the difference is between an IP address and a MAC address. Well, an IP address works on the local area network or the internet, but crucially, it can change. You can change your IP address, which is what you do if you try watching Sky Sports for free from India using a VPN. That's what you're doing. You're changing your IP address to do that. MAC addressing. You'll need to go back and learn that stuff, because this crops up with great regularity. MAC address is a unique identifier. Here's the key difference. The MAC address can't be changed. It's hardwired into your hardware, okay? So your PlayStation, your Xbox will have a MAC address. You can't change that. And that works on your local area network. It's used by the Ethernet protocol on local area networks, okay? And it's used by switches to direct data to appropriate devices. So IP addressing and MAC addressing is all about making sure that data gets to the right place, okay? Maybe take a bit of time to look through that in more detail, but being able to say 2 things about each of those addressing types, for example, IP addresses can be changed, MAC addresses can't be changed. That would be a really good start, okay? And if you can add more than that, that is better still. Standards. I think I'm going to get through this. Okay, well, I'm going to talk about standards and I'm going to talk about protocols. And the difference is that standards and protocols are similar, but they're not identical. So standards, it's a set or an agreed way of doing things. So for example, let me pick up something here that's a standard. Oh, this will do. So this is the, let's see if I can put this up here so you can see it. This is the lens cover for my camera lens. And this actually works at about 4 or 5 different lenses. Why? Because it's cheaper for the company to make one that fits lots and have to make lots of different fiddly lens covers. A better example could be something like, let's try this. Like this here. See if you can see that. So this is a USB-C connection. USB-C is a standard. And of course, Apple have been forced by the European Union to use USB-C rather than whichever format they fancy making. They thought about making that Friday afternoon. So what's the benefit of having agreed standards? The UK 3-pin plug, the power socket we all use, it's another example of a standard. So what have all these things got in common? It's a set or agreed way of doing things. And it means that it's easier to build software for different platforms because you know that it's going to work across different platforms, whatever it is you're trying to do. In other words, it gives wider compatibility and it's easier to collaborate on projects. These are examples: Bluetooth, Ethernet, IP, TCP, all of these. They are examples of standards. Okay, so we're going to look at the benefits of standards now. This definition is probably slightly better. You can tell it's important, this one, because I wrote the word important by it. Established convention for repeatable technical tasks, and it specifies an agreement that allows two things to interact. There we go. So that's a decent definition you've got there. I'm not going to go into that because we don't have time, and that's not relevant because that is just me giving you too much detailed. Here's what you need. Describe what a standard is and then say what the benefits are. It's used by all or some manufacturers. I've gone the wrong way. It's used by all or some manufacturers. I've gone to protocols. Hang on a second. There we are. It's used by all manufacturers or some, used in many devices, and it's about compatibility. That will be enough, okay? As long as you can talk about the benefits of having standards, a set way of doing things. So, for example, if you ever owned anything that Philips, the company Philips, have made, they just do their own thing, and they really don't believe in having anything that fits anything else. So, whatever you buy from Philips, it'll have its own type of socket which you've never seen before. Their stuff's pretty good, but they just produce crazy sort of sockets and plugs and ports. There we are. Okay, so that is, now we're on to protocols. 3 minutes, guys. I am going to stop at 7 because we've all got lives to lead. 5 of you still here, which is very impressive, guys, because I've talked a lot. Protocols. Right, protocols and standards. The difference is a protocol specifically is a set of rules that governs how data is formatted and transmitted. So literally, a protocol is just about, if you're going to send data, it's about how the data is put together and how it's sent, okay? How it's formatted and how it's sent, how it's transmitted. That is literally what a protocol is. So for example, TCP/IP protocol, that one governs how data packets are sent. HTTP, that's about how web pages are sent. FTP, that's about how files are transferred up and down from servers. The benefit of protocols is that it allows cross-platform, cross-device compatibility. The proof is in the pudding. If you can use, you can type in http www.bbc.co.uk and it works whether you're on a mobile, whether you're on your PlayStation, or whether you're on a standard computer, okay? It's a system, a protocol that works across multiple devices and platforms, whether you're on Mac, whether you're on PC, whether you're on Ubuntu. It makes no difference, all right? It will work across all of them. TCP/IP, well, I've got this on there. You don't actually need to know this. It's interesting, but you don't need to know it, so let's not even look at it. We do have, in fact, sorry, you do need to know that TCP stands for Transmission Control Protocol, and that it's the protocol is about, is about splitting data into packets, reassembling, I've already talked about this, and then making sure the packet arrives in the right place. And then the IP part of it is about the addressing. So these two work together, and one hands off to the other, and then it hands back, and then it hands to the other, and so on. So these two work in sync. They work with each other. These two protocols talk to each other. HTTP is about web pages. Hypertext Transfer Protocol is about web pages, okay? And it defines the format and of web pages and how they're transmitted. So all of these protocols are about how data is transmitted, but the data is in different formats, because obviously you've got data being sent. That's what's common to all of these, but it's how that data is being used. Is it on a web page? Is it an email? And so on, okay? All right, good. FTP is used to transfer files across networks. So say, for example, you are setting up a website, you might use FTP to upload all of your images, your video, your files, your web pages. You might use FTP to simply dump it all. It's a bit like an email application, except you can literally just take lots of files and dump them somewhere else, as long as you've got the address. That's how it works. Like all of these things, you have to have the address. It can be used to share files as well. Then you've got your email protocols, which are POP, IMAP, and SMTP. 2 for receiving, 1 for sending. This one, POP at the top, is an old-fashioned one. This goes right back to the early days of the internet. It's not really used much anymore. The current one, and that's just for receiving emails. The emails are downloaded from the email client, but once they're removed from that server, you can't then get them again. They're on the device. They've been taken down. Whereas the one we use here, the benefit of IMAP, of Internet Message Access Protocol, is that, again, it's for downloading emails from a client, but it supports synchronization, syncing, which means that if you say, for example, if you look at an email, if you open it, it becomes grayed out. So this means that across all of your devices, so say, for example, you're in school, you open your email, which says your homework, you click on it, you read it, and then it gets grayed out. If you then go and open that same email on your phone, it's still grayed out. So that's the idea, that it synchronizes the status, the state of your email across multiple devices. And then you've got this one, SMTP, which is for sending emails to a mail server and send emails between mail servers. Okay, because obviously you send your mail to your mail server, and your mail server moves it on to whichever mail server you are trying to reach. I've rushed through that fairly quickly, but that is that's the nature of it. By the way, your definition is communication protocols are sets of rules for transferring data. And that's what you need to worry about. I mean, obviously there are protocols for all sorts of things, but we're focusing on protocols for transferring data, okay, for the formatting and transmission of data. Those are your 6 protocols I've just covered there. Can you guess what they are? Top left, we've got SMTP. See what I did there? TP. Clever. We've got IMAP. We've got H. I'm very proud of this one, although none of my students knew what on earth I was doing. But we've got H, T, T, and then a bowl of peas. No, I like that one. We've got POP 3, and then we've got I like this one. We've got T, C for the glasses, and P, and then we've got, okay, I've run out of ideas for FTP, but that's what it is, FTP. So those, ladies and gentlemen, are the ones that you need to know. Guys, you 5 have done amazingly well to listen to a whole hour on a Thursday night, so congratulations to you. It's been a pleasure. If there's anything else that you want from me, you want me to cover, let Mr. Vallely Godfrey know, because we'll be in contact and talking about what we can do next for you, okay? But otherwise, I will see you same time, same place next week, and we can go and talk about the next topic. I can't actually remember what the next topic is, but we will. I will send the link through, and you can have a look at that next time. Okay, guys, take care. Have a good week. Bye bye.